to module 2.2. In this lecture video, I'm going to show you how to multiply fractions. But before we talk about multiplication of fractions, let's take a look at reducing fractions. Reducing fractions to lowest term. So a fraction is reduced to the lowest term if the numerator and denominator have no common factor other than 1. Okay, that's called the simplest form. When reduce fraction to the lowest term, all we need to do is reduce numerator with the denominators. So there are two ways we can reduce a fraction. Number one, using your multiplication table, make sure you recognize the numbers on the multiplication table. If you run into a number you don't recognize or that is not on the multiplication table, you can use the concept of prime numbers, divisibilities, or finding all factors of a number to help you to reduce fraction. But more importantly, always try to recognize, the number that are on the multiplication table. So if I need to reduce 30 over 40 to the lowest term or the simplest form, I know 30 is on multiplication table, so is 40. So as a matter of fact, both of them is on their multiplication table of 5. But most of y'all also know on the multiplication table for 10, 30 and 40 can also reduce by 10. Reduce by 10 simply means we will divide the numerator and denominator by the same number. So that will actually give me 3 over 4. Now, what will happen if I will reduce 30 and 40 by 5 instead of 10? Well, if you do that, then that means whatever this answer is, you can reduce them again. So make sure you reduce the top and the bottom with the same number. 30 divided by 5 is 6. 40 divided by 5 is 8. And we recognize 6 and 8 is under the multiplication table 2. So if I reduce them again by 2, 6 divided by 2 is 3. 8 divided by 2 is 4. So I get the same answer. Now, if you leave it at 6 over 8, the computer actually counted wrong. All right, 30 over 27. Reduce 30 over 27. I recognize 30 and 27 is under multiplication table 3. So if I reduce the top with the bottom by 3, that will give me 10 over 9. So even though this is an improper fraction, we can actually leave it like this. Some of these problems will tell us to convert into a mixed number. All right, reducing 5 over 20. 5 over 20. 20 and 5 are both on the multiplication table 5, so I can reduce them by 5. Divide top and bottom by the same thing. So that will give me 1 over 4. So the way how we multiplying fraction is basically the same method. Okay. As you can recall in module 1, we talk about multiplication between anything is only considered as one term. So within one term, I can reduce my top numbers with the bottom number. So when we multiply fractions, I need you to remember to reduce your fraction to the lowest term before multiply. That means while the numbers are small, we want to reduce the top with the bottom before we multiply them side by side. So just pick a number on top, go against a number in the bottom. I see 13 on top, can reduce with the 13 in the bottom by 13 itself. So that will leave me with 1 and 1. Let me put red. All right, I got 4 on top, can reduce with a 32 in the bottom by 4, because I know 4 will go into 32 evenly. So that'll be 1 and 8. So let's check the number on top. 1 and 1, 8 and 1 in the bottom. So nobody can be reduced top and bottom. So now I multiply side by side. 1 times 1 is 1 over 8 times 1 is 8. Okay, that's all we have to do. So rather than multiply first, then reduce, I recommend students always reduce top with bottom first, then multiply. So there is no such thing as cross reducing, okay? No such thing as that, cross reduce. When we reduce fraction, when we multiply fraction, we simply reduce the top numbers with the bottom numbers, okay? And the reason why we're allowed to do that is because multiplication between anything is one term. Everything within one term, we can try to simplify. All right, let's take a look at a whole number times a fraction. So this is when we need to remember every whole number when we're dealing with division or fractions is always over 1. So that actually make the 6 to be on the numerator can reduce with a 14 in the denominator. So top and bottom reduce by 2. That should give me a 3 up here and 7 down here. So let's look again. I got 3 on top, 5 on top, only 7 in the bottom other than 1. So there are no more common factor between the numerator and the denominator, so I cannot reduce anymore. So 3 times 5 is 15 over 7. I'm just going to leave it like that. All right, let's do one that's more interesting here. I recognize, so this is multiplication, so we reduce. And I recognize the 49 on top with my 56 in the bottom because both of them is on the multiplication table under 7. So that means if I would reduce 49 and 56 by 7, that means I divided by 7. I should go, so 49 divided by 7 is 7. 56 reduced by 7 will give me an 8. All right, let's see what else I can reduce. So I got 7 on top, 65 on top. I got 26 in the bottom, 8 in the bottom. So I know 7 and 8 cannot be reduced anymore. 65, I don't quite recognize 65. So let's think about this. I know divisibility by 5 can go into it. So if I would think about divisibility by 5, 5 will go into 65 about 13 times. So this number up here, if you think about it, is really 5 times 13. And both of them are also prime numbers. So this is where prime factorization can come in place. Now I notice 26. If I use prime factorization using a prime number 2 or divisibility by 2, I know 2 can go into 26 13 times. So this 26 down here is basically saying 2 times 13. So the top 13 and the bottom 13 can be reduced. So you can never reduce bottom with the bottom. It got to be top with the bottom. So what I got left with is 7 on top, 5 on top, 2 in the bottom, 8 in the bottom. So if I multiply them side by side, 7 times 5 is 35 over 2 times 8 is 16. So since I could not reduce any more before I multiply, then this cannot be reduced again. All right, let's try another one. Multiplication between two fractions, reduce top with the bottom. So I'm just going to pick the 7 on top. I know 7 can reduce with the 21 right below it, or 7 can reduce, can 7 reduce to 48? No, not really. So I'm going to do 7 and 21, top and bottom. If I reduce 7 and 21 by 7, that leaves me with 1 on top, 3 in the bottom. I know 36 and I recognize 36 and 48 on the multiplication table under 9. No, under 6. So I'm going to try 6 first. So if I reduce them by 6, that will be 6 and 8. All right. 36 divided by 6 is 6. 48 divided by 6 is 8. So I can reduce them one more time between the 6 and the 8, or 3 and the 6, top and bottom. Doesn't matter, just pick one to reduce. I'm going to pick the 6 and the 8, reduce them by 2. That will give me 3 on top, 4 in the bottom. So now I have 1 on top, 3 on top, 3 in the bottom, 4 in the bottom. So the two threes, top and bottom, can be reduced one more time to be 1 and 1. So my final answer is actually 1 over 4, right? 1 times 1 is 1, 1 times 4 is 4. Now, what about 3 fractions here? Same thing. As long as I'm picking top number with the bottom number, I'm good. So just looking at the 30 on top, I know 30 can reduce with 9 because I can reduce them by 3. I can do 30 with 34, reduce them by 2 using prime factorization or divisibility. I know the 27 and the 9 can reduce by 9. I know the 24 and the 16 can be reduced. The 24 and 34 can also be reduced by 2. So where do I begin? Well, it doesn't matter. You just start out with one number on top with the one number in the bottom. So I'm going to make my life easier. I'm going to go with, it doesn't matter. There's no set way to do it. As long as you take a top, reduce with the bottom, you're doing it correct. I'm going to pick 27 and 9. Reduce them by 9, so that gives me 1 on top, 3 in the bottom. So normally what I do is whatever number I wrote, I use that number, doesn't matter if it's on top or bottom, and go look on the other side. I know 3 cannot reduce with 34 or 16, so I'm going to move on to my 24. Or I can move on to 30, does not matter. I'm going to pick 24 and 16, reduce them by 8. Right? Because 8 can go into 16 2 times, 8 can go into 24 3 times. So I just roll a 3 on top. That can go against with 34 in the bottom, but not really, because they cannot be reduced. I also roll a 2 in the bottom, so I'm going to look at this 2, and I know 2 can reduce with 30. So that will give me 1 and 15. So I just roll 15 here, so let me think. 15 and 34 cannot be reduced. So 3 and 34 cannot be reduced. So that's it. Now I multiply all my number on top together and all my number in the bottom together. So 34 times 1 is still 34 in the bottom. 15 times 3 times 3 again. I know 3 times 3 is 9. So 9 times 15. 9 times 5 is 45, carry 4. 9 times 1 plus 4 is 13. So that's 135 over 34. That would be my answer. All right, so there's no set pattern how you begin. As long as you take the top number, reduce with the bottom, you're doing it right. We just got to keep on checking, make sure no other number top and bottom can be reduced. Right? So no problem with four fractions. Same thing. All right, 36 means 36 on top over 1. Oops, sorry. Let's take a look. Let me make it too small. All right, 36 means 36 over 1. So I'm just going to pick 36 with a 72. Hang on a second. All right, 36 and 72 can be reduced by 9. 9 go into 36 4 times. 9 go into 72 8 times. So I just wrote a 4 on top and an 8 in the bottom. So I notice my 4 on top can reduce with the 4 down here right next to my original 72. So when they cancel out, they become 1 and 1. All right, I wrote an 8 in the bottom just now, and that can be reduced with a 2 on top or the 44 on top. Doesn't matter, just pick one. I'm just going to pick with 44, okay? No cross reducing. As long as the top reduced with the bottom, I'm doing it right. So I'm going to reduce them by 4. 4 going to 44 is 11 times. 4 going to 8 is 2 times. So I just wrote this 2, and that 2 can reduce with the original first 2 on the very top. That will be 1 time each. So let's see what I got on top. I got 1, 1, 3, 11 on top. I got 5, 1, 1, 1 in the bottom. So the 11 on top cannot reduce to the 5 in the bottom. So we multiply them side by side. My answer, 11 over 5. That will be the answer. Okay. All right, let's take a look quickly on the application problems. In a class of 60 students, 36 receive a grade of A. So what fraction of the class did not receive A? Well, let's see. 36 students got A. So that means the remaining student out of the 60 did not get an A. So 60 minus 36, that will be 10 minus 6 is 4. This becomes 5 minus 3 is 2. So that's 24 students did not receive an A. So that will be 24 students out of 60 did not receive an A. I can reduce them by I can actually reduce by 12, but I'm going to do 6 first because I do recognize them. I do recognize 6 can go into both of these. 24 divided by 6 is 4. 60 divided by 6 is 10. So let me write this down. I reduce by 6 first. Now 4 over 10, I can reduce one more time by 2. So that will give me 2 over 5. So when I reduce by 6 first, then reduce by 2, that means I could have reduced them by 12. Okay, 2 over 5 will be the answer. All right, let's take a look at this problem. If you go on a road trip of 240 miles in the mountain, 16 out of 17 of the trip is downhill. How many of the trip are not downhill? So if 16 out of 17 are going down the hill, that means 1 out of 17 of the trip is actually not downhill. Now, where do I get a 1 from? Well, because I know 16 over 17 just need to add 1 more out of 17 to become the whole entire trip. Okay, 17 out of 17 is equivalent to 1. So that's how I know how many. That's how I know in terms of fraction how much of a trip is not downhill. All right, times by the 240 miles total. Okay, and that will tell me how many miles are not down the hill. So I'm going to treat the 240 whole number times a fraction that's as over 1. We just got to try it. Okay, 17 going to 240 because 17 is a prime number. So this prime number need to reduce with that 240. Let's take a look. 17 going to 24 one time. If I subtract, I actually end up with 7. Bring down the 0. So 17, let's see, 7 times 7 times what number ends with a 0? That got to be 10. So 17 and 240 cannot be reduced. So my answer would just be 240 over 17. That will be how many miles that are not down the hill. So in this lecture video, we talk quickly about how to reduce fractions, and then we talk about use the same technique, reducing top with the bottom when we multiplying fractions. All right, that will conclude this lecture video. Thank you for watching.